There we go. All right. Good morning, good afternoon, good evening to everyone around the world. It's great to be here. This is Martin Hubel, your host of the DB2Night show. Today is show number 219 of the LUW version of this show. And I'm honored to have with me a real star in the community, Ember Crooks. How are you doing today, Ember?
I'm doing great. How are you doing, Martin?
I am fine. We actually had snow here, which is rather unusual this early in the month of November. We normally can expect it by the 15th or so. So we got to watch people having bumper cars around Toronto. That seems to be an annual sport in the early winter. And they also seem to do it at the end of the year, too, when they've had enough and they just want to drive fast, and they shouldn't be doing that. But that's life of the city where there's a little bit of snow and 9 million people. They get to go out and bump people around. Okay, let's get through. Here's our social media page, as always, hashtag DB2Night. Martin needs to remember to tweet a little more, but I'm doing my best, and we'll keep working at that. And we have our LinkedIn group, of course. Here's our legal disclaimer, which I will not read, but it basically says things are being recorded. Everybody owns their trademarks, and have a nice day. So there's our agenda for today. We have some quick announcements, our studio audience polls, which we love to do, and then we have the presentation, and audience Q&A is through the tool that's available within GoToWebinar. You can put your questions in there, and I'll be monitoring the queue, and at an appropriate time, I shall interrupt Ember and ask the questions. So and that'll be, as always, how we do it. And then we wrap up and send you on your merry way, hopefully by 60 to 75 minutes from now. Upcoming shows. Next month on LUW, we have George Backlars of IBM Toronto. He's going to talk about DB2 and Jupyter notebooks. I know, Ember, that's a topic that's near and dear to your heart as well. We'll hear it from the IBM side. That'll be interesting to hear. And also in January 10th and onwards, I'll be lining up speakers, and I'll certainly announce those on our next show in December. And also next week, I expect I'll have some shows lined up. I would certainly want to have January through April scheduled by the end of the year. Also on the Z side, if you're bilingual, we have Adrian Burt next month speaking on distributed best practices for DB2 today and tomorrow. And also to finish off the year on the Z side, we have Tony Andrews of Themis, and that's DB2 best developer features version 9 to version 12. And that's sort of Tony's top 10, top 20 list of good things to do. And Tony is a great speaker, and I believe you'll probably see some carryover between LUW and Z. So even if you're just an LUW user, you might find that show on December 20th to be of value to you. As always, we have a link to a demo, and if you watch the demo, DBI is happy to send you a gift card. So just follow the link, register, and enjoy that, and get your gift card. Here's our winner from the last show, was Jeff Simmons of Dillard's. He's been contacted, and he's gotten a gift certificate to somewhere. It says Amazon. I guess it's Amazon. And here are our sponsors: is DBI, the founding sponsor of the DB2Night show, and yours truly, Martin Hubel Consulting Inc., as the host of the shows. I had an unfortunate thing happen with Charlie this summer. I've put up this picture before. We have the IBM content on. I've moved that over to the left with IBM eating a bone from an IBM dinner here in Toronto, and he's still doing that. But Charlie's getting a little old, I'm sorry to say. Unfortunately, our pets don't live as long as we do. And actually, I've still got his snow wear in on the right-hand side here. He's got his little coats he wears and boots. Although it's so hard to get him to put them on and enjoy it and want to go out these days when he's 14 and a half years old. Unfortunately, I also learned this summer that his eyesight is going. This is neighbor just one down from where our driveway is. They put a filing cabinet out to garbage, and I let Charlie off leash, and he runs to the front door and waits for me, and it's kind of cute. And it makes me know that he knows where home is and all these things. Unfortunately, this filing cabinet was out to garbage, and Charlie, I let him off leash. I didn't even look up, and I heard this big bang. Charlie ran right into the side of the filing cabinet. Oh, poor guy. It didn't hurt him. It was kind of like, what happened? And anyway, he's sleeping about 3 or 4 more hours per day these days. I think when we got him, he was a little nervous. Now he's calmed down, and he's a more chill guy. But he wasn't expecting the filing cabinet. It took him a good 2 weeks to get a pickup and get that off the street because it's a special item. The garbage men won't take it as it is like that. But so I had to keep him on a leash until that went away, because it might be cute for some people to take videos of pets doing silly things, but I didn't want to have him hurt himself. So eventually it went away, and things returned to normal for dear old Charlie. Okay, let's do our polling questions. These are relatively short today and should go through quickly. Standard things that we have is what versions of DB2 are you currently running? And, this is a multiple response, I hope, so you can fill in what you need. Just finding out if anybody's running 11.5 yet. We got 1 or 2 respondents on 11.5. And we still have those people that like the old stuff. So I'll give, we've got about 2/3 of our audience voting. I'll give you about another 5 or 10 seconds, and we'll close that off, and we'll share that result. Basically, we have 15% of our audience running 11.5. Almost everybody's on 11.1, and we have some old stuff down there at the bottom. All right, next question. Which commercial databases do you currently run? Is that set for multiple responses or just single response?
I can't click on it, but it looks like single response.
Yeah, it does, doesn't it? Let me close that. I'm going to fix that right now. I'm into the rid of that. Sorry. The things that you run across. Won't let me do anything with this. I need to get a bunch of stuff out of the way here. Databases do edit poll. I need multiple answers on that. And then update. And the other one below it here is also needs multiple responses. There we go. It's amazing what you can do when you actually know what you're doing. Thanks, Jason, for letting me know. I'm really good at getting some things a little. Let's see if I can open this again. I don't think it's going to let me, but actually, no, I don't think I can open that again. All right, but the next one will be fixed anyway. Okay, actually, this is letting me now do it as a new question. So this one is providing the response I originally wanted to see. Interesting watching Sybase. I worked for a vendor that did Sybase tools initially. It was called Embarcadero Technologies, and Sybase is still hanging on. It sort of got new life when SAP bought it, and they've come out with a product called HANA for the SAP world. So let me close that off and share the results there. we see that, well, anybody watching a DB2Night show has, of course, 94%. I wonder who didn't have DB2 LUW or Z that is in the audience today. And the next one we have is, which of the open source databases do you have and use regularly? This is rather interesting. We've got a nice collector series there of open source DBMSs that people are using. And I think we'll, for in the interest of time, we'll close that and share the result. And you can see that people are using all of those products. MongoDB, MySQL, and Postgres are the most popular by quite a bit. And with that, I believe I am through with questions for today. Thanks for your answers and thanks for your participation. So we'll move along now. And Ember, you're up. Let's find my attendees panel here. We'll make you the presenter. You should have a message for pop-up right now.
There it is.
And I see your screen.
Great. All right, so this is a presentation that was given at both iDoug EMEA and iDoug North America, and so that's why you might see some of the dates and times from those. This presentation really comes from a place of what I do every day, what I did every day. When I worked with Extivia, I would go out and I would go into some of my clients' environments, new people that weren't clients, people that were clients, but wanted a good overall thorough going over of their environments and do a health check. And the reason I'm kind of going through this is to share some of the things that I've learned, some of the ways that I look at a health check. I'm hoping that this can help other people, you know, really dig into their health check. The first thing that we always had to go through when we're looking at doing a health check is the scope of that health check. Am I looking at the entire environment? Are there specific problems? Sometimes people would come in with specific problems and we dig into those more, whether that might be storage or in one case I did a health check that was really focused on HADR. Actually, a couple of cases did health checks that were really focused on HADR and digging into that. So knowing what aspects you're really looking at, where you're going deep and where you're expected to just kind of look at the high level of things. So the idea here is that you're looking at the health of a system, but you're also looking for potential future problems based on misconfigurations. So not just what's right and what's wrong in the system right now, but what are the pain points out there that you might run into in the future if you don't implement some best practices. So health checks in your environment, you have to consider why and when you might want to be doing health checks. Generally, I'm hoping everybody has good monitoring and alerts to find imminent or existing issues, but health checks are really something I think of as more proactive. They involve the human element of a DBA's judgment. So somebody looking at a system and saying, this is good, or this is bad, this is a risk, or this is not a risk. Really digging into it with that human element beyond the automation that you might have in place day to day. And I found the most useful health check timing to really be several things. First of all, whenever I'm starting to support a new system. So new systems, you know, for a consultant, new systems come in and usually in the form of new clients, but they can also come in even when you're not a consultant. There can be a system that somebody else spun up, even if it's somebody else on your team, even if it's a talented DBA who built the system and is supporting the system, there are still things that all of us can miss. Also periodically, so we're getting really close to Black Friday and Cyber Monday right now. So if you're working at a place where those are peak periods, it's actually a bit on the late side right now to do those since we're in November. We did health checks for them for our retail clients starting back in August so that we would have time to implement any findings from those. And then finally, periodically, it's something where maybe once a year, maybe once a quarter, maybe once a month, depending on how in-depth they're doing with a health check, it can make sense to use those different kinds of timings. So once we've defined when to do a health check and what's included in the health check, we need to talk about who is performing the health check and who is implementing the resulting suggestions. So performing the health check, the general idea with performing the health check is that you need somebody experienced with DB2 and preferably somebody who hasn't been working with that particular system. It can be useful for somebody who's been working with the system to do a health check as well, to really go through, but in general, having a DBA that knows what they're looking for and is not used to the system might find some of the things that doesn't happen that don't happen in that system that maybe should. And then when you're talking about who should implement the resulting suggestions, it's a lot more open-ended because it can be somebody who supports it day to day. It can be the DBA who did the health check themselves. Any DBA who's really qualified and who knows your company's process, because we're talking about implementing changes. So this person is going to need to know, do I need to open a change ticket? Who needs to approve this? If I need an outage, how do I go about getting an outage? That sort of thing. So the health check process is really kind of circular. We start by running some queries and calculating some key performance indicators. We use those results to decide where we're going to investigate further and write up a report that details all of the things that we're checking. Well, not all of the things, but at least the highlights of the things that we're checking that were correct. And also it really calls out the things we're checking that there was some kind of a problem with, that we have some suggestion around. After we've done that, we want to implement the recommendations, and then whenever the next health check is, we kind of start all over again. There can be some recommendations where the tuning requires multiple iterations. You know, we need to change this one parameter, and then we need to let normal volume run against that database for a while and observe what happens, and then tune it a little bit more. So when you're writing a health check report, there's several things you need to think about. One is you need to think about your audience. I've had health checks where the people bringing me in were executives and they want me to find all the mistakes that their current DBAs are making. That's a difficult position to be in. I've had health checks where the person bringing me in is the DBA and they're really looking for support in some of the things they've been pushing to change in their system over time. That one's a little bit easier to support in most cases. But think about who your audience is while writing that health check. Is your main audience executives? Is your main audience experienced DBAs? You're going to write things a little bit differently depending on who's the main audience and who's going to be reading this. In a health check report, you're also going to want to detail action items, so give very specific things that need to be changed. If you have something that can be fixed with a one-line command, include that command to actually implement the change. And also include links to supporting documentation. There are a lot of cases where people want to see more than just what you think, right? So include links to the DB2 Knowledge Center or to blog entries or to something else that supports what you're saying. The point of the health check is really communicating, and the things that you're communicating is for each item kind of the priority of that item. Is this something that I think might blow up the system tomorrow? Well, that's pretty high priority. Communicate the risk, both the risk of not changing the item and leaving it the way it is, and the risk of making the change to the item, and the level of effort. How much work is it to actually implement a fix to this particular area? For prioritization, I go with simple and clear. I usually define 3 different levels that work for me. Usually I have a minor, a medium, and a major. They all start with M. I don't know why the alliteration, but that's generally the direction I go. And then I think about the factors that can impact the priority of the recommendation. So for example, I was doing a health check and I ran into a situation where I had table spaces that were approaching the maximum possible size. And this is not a set maximum. They were regular table spaces, not large table spaces. They were 4K. They were approaching 64 gigs. When they hit that 64 gigs, they can't be expanded anymore. There's nothing you can do until you actually go out and convert it to a large table space and reorg the indexes. So when I saw that, I immediately brought that issue up. I didn't wait for the report. I went to the people I was doing the health check for and I said, hey, look, we've got this issue. This is a major thing that could cause an outage today even. So there's some that I'll bring up like that, and those will absolutely ends up being a major recommendation. There's a high risk of a outage being caused if a fix isn't implemented. There are others that end up being important, but they might be things that take a while. So one of those sometimes ends up being reorganizing how tables are placed into table spaces. That's something that can really help performance, both from a regular activity and I/O, and also especially for the backup times. So something like that is going to probably be a little bit lower priority because it's not something I want anybody to rush into. It's something that's going to take some time to implement in multiple different environments. So when you're doing a health check, you're basically comparing a database system to something. So you have to have something to compare it to. It's best to have your own standards and best practices and to document those standards and best practices. You can absolutely start with IBM's published best practices. I have a lot of items out on my blog at datageek.blog where I tell you what my best practices are and why they are that way. But in general, you need to have your own standards. You don't want to just say, I'm comparing to whatever the good thing is. You need to define what that good thing is. And those standards are dynamic. They should change. And as you learn and see new things, that's something that absolutely for me, as I learn and find out new things, when I listen to John Hornibrook on the last DB2Night show talking about stats, it makes me more enthusiastic about real-time stats and auto stats. You know, there's things like that that change over time. There was a time when I would have said absolutely not to automatic run stats. And now I'm a much bigger fan of automatic run stats. So as things change, as technology changes, as disk speed changes and capacity changes and all that, you need to make sure that your standards are changing along with those. Now that we've talked about kind of the health check in general, I want to dig into some specific areas that I go out and check. And just so everybody knows, I'm going to, later in the presentation, I'm going to give you a link to the Jupyter notebook that I use that has most of the SQL that's in here. So don't frantically take notes. You don't have to sit and replay the recording over and over again. There is a Jupyter notebook that will include all of the SQL to kind of go through some of these areas that I check when I'm looking at a health check. So the first thing that I always look at is DB2 version and patching to try to figure out what version makes sense in this environment. And there are a number of different questions I ask when I'm going into this because the right answer is not always the most recent. There are a number of different factors that go in here. First of all, you have to look at what versions are supported by an application vendor. So if it's a vended application, you don't want to go outside of what the application vendor supports. And sometimes this involves pushing the application vendor and asking the application vendor to go out and support a newer version. And this even applies when IBM is the application vendor because sometimes IBM isn't certifying the newest versions of DB2 as fast as we might like them to. It also depends for me how cutting edge is the client up for. And if you're an employee, then that's how cutting edge is your company up for. I have worked with clients who are enthusiastic and they want to be on the most recent version. They're interested in that. They want to see the new features. They want to be involved with that. And I've worked with clients who are still today on DB2 9.7 and have absolutely no interest in moving, even when I describe the horrors of trying to deal with a problem issue, a case with IBM when you're that far behind and that far out of support. So the things that I'm going to do here is I'm going to generally recommend the most recent stable version. And to me, the most recent stable version is anything that has at least one fix pack. That used to be 3 fix packs. So I used to, back on 9.7, I wouldn't recommend going to the new version until there were at least 3 fix packs out. However, with the way IBM is doing cloud, there's a lot more testing that goes in before we actually see the code. So as long as I've got 1 fix pack, I'm happy with it, but I'm not generally going to go with GA. So that means that on DB2 11.5, it was released in June. I'm not going to be going to it until next year when the first fix pack is released for on-prem. I also look at the most recent stable fix pack. I try not to go to a fix pack immediately because sometimes IBM retracts them. So that means at least 1 week old for me. And this is really only ends up being a short paragraph in the health check report. So it's not something that takes up a lot of the health check report. It's just something that is always there at the beginning. I consider, and I've put here how I determine the priority based on what's going on. High priority is when the version in use is past end of support or the end of support is very, very close. And the base code used for the fix pack is more than 5 behind the current. And I do see this all the time. I come in and see old code. If it's really close, if it's on the current fix pack or 1 fix pack behind, then it's not as high of a priority. It just depends on those factors. The other thing to consider with a new version or a fix pack is how high risk or low risk is it to implement a new version. So there are some environments where it's high risk to upgrade to a newer version. Maybe it's a very large jump in the version or fix pack, especially if it's one where you have to do a skip level where you put a version in the middle in order to do the upgrade because you're more than 2 or 3 versions out of the current one that you want to get to. If the DBAs who will be doing the upgrade have no experience with upgrade, that can be a high risk as well. They're not used to it. If there's no test environment available, especially for larger environments, that's sometimes true where there might not be a test environment available to test out the version before you actually use it. When there's no high availability or disaster recovery solution, or when the vendor doesn't certify the target DB2 version or fix pack. Some of those might be high enough risk for me to say don't do it, but in general, you need to keep moving forward with fix pack. One of the things that I do when people are far behind is I'll go out to IBM's list of hyper APARs and show them all of the different APARs that are fixed in a particular fix pack, especially the hyper and the security ones. That's something that can be really visually stunning for them to see that each and every fix pack, we're talking about probably at least half a dozen security related APARs that are fixed in it. And when you add those up over the course of multiple fix packs, multiple versions, that can be pages and pages of security related things that are fixed. So there's a very high risk of not being on a current version, on being on a version that has so many security compromises that are possible. After that, I will generally dig into disk and tablespace issues. I have my own file system layout that I have published on my blog and that I'm looking for. So I'm looking to make sure that things are well isolated. I don't want DB2 to be running on root or on home. And those are things that I have seen in the last year. So that's definitely something where sometimes you come into an environment and somebody else installed DB2 and the databases have all of their data on root, and that's extremely risky. That's not something we want to see. So that's kind of the sort of thing that I'm looking at to start with. After that, I'll look into where the fastest disk is used. If I'm working with an OLTP environment, then my first location for fast disk is going to be transaction logs if I have SSD available. And then my second choice in OLTP or my first choice in an analytics environment is going to be temp space. Those are the places where I can apply SSD and make the biggest bang for the buck. I'm also looking to see what the I/O layout looks like. And a lot of times as DBAs, it's a black box. The storage people say, here's your storage, and you don't know what's going on behind it. But if you do know some details about it, that can help you with some configuration around the I/O. And really looking for I/O weight to see if that's a problem for that particular database. I went in and did some work with a client who was running on AWS, and the standard EBS volumes were not fast enough for their database and what they needed. And we were able to see that in the statistics about the database, and we were able to spread data across multiple EBS volumes and solve the problem that way. So there's a lot of different I/O type problems you can go out and look for. So part of what you're doing is really comparing two best practices, just like we were talking about. You have your standard, you have best practices. There are published IBM best practices on storage. So this is an important place to go. My best practices are on my blog. IBM has some published best practices as well. But the real thing is to create your own best practices documentation, especially if you're working in an organization with more than one DBA. You need to agree with your fellow DBAs on what the best practice is. What's the standard? What are you aiming for? I also look at table space layout. Sometimes table space layout is dictated by the application or by the vendor, but sometimes it's something that the application or the vendor will let you change as well. These days I'm looking to see if there are any SMS table spaces still in use outside of temporary table spaces, because they are deprecated for user data at this time. So that's something that I want people to be aware of. Deprecated means that IBM is no longer improving anything around them, and that at some point in the future, IBM will be removing support for them. So that's the thing that I'm really worried about with deprecated, is that at some point in the future, support might be removed. I'm looking for DMS table spaces that are non-reclaimable. This makes it, if there are any DMS table spaces that are non-reclaimable, it makes it so it's very difficult to delete data and have that space available to be used in other ways. I look for non-large table spaces approaching the maximum possible size, because that's a problem I've seen several times in the last few years with clients coming in. I'm looking for any table spaces that are not syscat, that are regular instead of large. I really like table spaces to be created as large these days, because the maximum size limits of the regular table spaces are pretty low by today's standards. I want to look and see if the data is balanced across table spaces to optimize backup speed. The number one thing that you can usually do to speed up a backup is to make sure that your data is balanced across multiple table spaces. I look and see if there's a vast proliferation of table spaces. There can be some valid reasons, but it's kind of frustrating to have to deal with a lot of table spaces, and there's not a lot of gain that we get out of it these days. Most of these cases, when I see it, it's somebody coming from ZOS. They're putting one table per table space, and for most cases, that's just not required these days. There's not a lot of benefit that we can get out of it. So I prefer grouping of tables within table spaces. And I also look and see if there's a lot of free space in the table spaces that isn't needed. I took a look at one client that was doing a one table per table space layout recently, and I figured out that across the 2,000 table spaces that they had, had over 100 gigabytes of unused table space in a terabyte database that they could reclaim just by being more careful about their space allocation, even if they were going to stick with the one table per table space layout. So there are several goals of an optimal table space layout. First, meet or exceed your vendor requirements, balancing data across multiple table spaces to facilitate a fast backup, reducing wasted space. For OLTP, the goal is to reduce the amount of data required to return just one row. That means generally smaller page sizes. For analytics environments, maximizing the data that is read together. If you're using Blue, you want to separate columnar organized and row organized tables. I also like to group together tables that need to be independently restored, just because table space backups are actually usable and good things to do these days. So if we can group together those tables, then that makes a lot of sense. And to take advantage of separate I/O paths if they actually exist. I am not a big fan of data and indexes separated just for the sake of data and indexes being separated. If they're on the same disk, it doesn't make a lot of sense to me to separate data and indexes into their own table spaces. If I have fully separate I/O paths all the way through, then yes, that might be something I'd be more willing to consider. But just for the sake of separating, it doesn't make a lot of sense to me. Now, there's a geometry problem that you can actually run into when you're allocating, and I've seen this in some vended databases from IBM, where they put the data into a 4K page size, and the row size was just barely over half a page. So almost half of every page was wasted in that scenario because they couldn't get another row on the page. There was only room for one row on that page. And by moving that to a larger page size, you can get a much more efficient allocation of space. So in this case, in this particular case, with a row size of 2042 bytes, that's the same in both of these examples, and a page size in the top section here of 32K and a page size in the bottom section here of 4K. And then in the top section, I only need one page to support all of this. And in the bottom, I need 16 pages to support the same thing. You can see that in the top example, I have 32K allocated and 32K used. In the bottom example, I end up with almost twice as much space allocated, but only half of it used. So thinking about some of these geometry problems while you're laying out table spaces can be really useful for avoiding problems like this. So when I'm looking at table spaces, I'm looking, these are kind of where my priorities go as far as high priority and low priority checks and fixes. Where it really depends is if the data is concentrated in one table space, is that causing long backup times, and do we care? Some people are very cautious about their backup times, and some people are less cautious. If your data is concentrated in one or two table spaces and that's causing long backup times, that doesn't necessarily mean that your restores take a long time as well, because restores are still parallelized even when the data is mostly in one or two table spaces. So it's not quite as bad on restore. So it just depends on what the concerns and problems are in that particular case. Now, this is an SQL statement that I use to help me determine what I need to monitor. So this is something that I'll use as part of a health check as well. This is what the SQL looks like, and this is what the output looks like. So what I'm doing here is I'm building some logic into the SQL to help me decide whether I need to monitor the space on an ongoing basis and whether I need to, what my threshold should be for monitoring the maximum size on an ongoing basis as well. So this gives me a lot of that data right here. And you'll see if you download the health check notebook that there are actually several different SQL statements that I run about table spaces to figure all this out. You can see in this particular example, I do have a concentration of data in one particular table space. It's almost entirely in user space 1. This is a WebSphere Commerce database, and so that's a pretty common problem in WebSphere Commerce databases. Now, what I do is I don't just look at the numbers. Using Jupyter Notebook, it's awesomely easy to come up with graphical representations of how things are, and this is one of the areas where I use this. So it's very clear in this picture that I have one table space where most of the data is. And then I have a couple of others that have a little bit of data in them, but it's very easy to see that I have a Pac-Man type pie chart here, meaning that I have one table space that is really hogging the space. So instead of looking at numbers, I just take a quick glance and I can see, okay, this might be a problem. This might be something that I need to look into in this particular environment. All right, so let's go into memory layout and balance quickly, and then we'll be ready for the DBI commercial in the middle here. I always graph the balance of memory for the databases, and so what this does, so this particular environment here, I found this graphing really helpful. This is an environment I supported where I had 4 different databases that were all 4 different instances that all had one database each. So I had 4 databases on the server. And when I came into the environment, a different company had been supporting it from a DB2 perspective. And I went to run this particular pie chart. This came out entirely pink. The entire thing was one color. And I'm looking at it going, I'm not sure what's going on there. So when I dug into it in more detail, I discovered that the people who had been supporting these databases hadn't set a limit on instance memory, and this was on Linux. They were using STMM, and they were allowing each one of those instances to decide their own limit for instance memory. And what I found on Linux is that DB2 will have each one of those instances attempt to allocate 80 to 90% of the memory on the box. So I had 4 instances trying to access 80 to 90% of the memory on the box. And the only reason it hadn't caused a crash yet at that point is because the system was vastly oversized. So there wasn't a huge need of memory for those various instances. So that's an example of how with a health check, we were able to prevent an outage. We were able to prevent a problem from happening by recognizing that and by setting static values for instance memory for each of these so that it would go in a nicer pie chart like this that we can see where each instance has its memory section and there is some memory left over for the system as well. Now, charting by database can be useful as well. There are a couple of different ways that I chart by database. This is kind of what I would expect in an OLTP environment, that buffer pools are taking up the majority of my memory at the database level. But this can be useful to help you understand how much of your memory is being taken up by sort, and do I have any heaps that are kind of going overboard and taking more memory than I really think they should. When I'm looking at KPIs related to memory, I'm looking at the STMM settings. Is it in use? And if it is in use, is it properly limited? I'm looking at my buffer pool hit ratios because I find that buffer pool hit ratios are the canary in the coal mine. When DB2 starts to feel memory pressure, buffer pool hit ratios are one of the first things that go down. So that's something that can help me understand if there's any memory issues in this particular database. I'm going to look at log buffer size and look at log pages read and log pages written to understand if the log buffer size is appropriate. I'm going to look at the sort overflow percent and the package cache hit ratio. Package cache is one of the areas that I'm likely to remove from STMM in some cases. And I'm going to look for lock escalations as an indication that the lock list may not be large enough. So when you're going into an environment that has STMM, I like to put up a diagram like this so you can think about what STMM controls and what it doesn't. So the things listed on this page, those are the only things that STMM controls. Anything else that you set to automatic uses a different algorithm. It's not using the self-tuning memory manager. The self-tuning memory manager will go out and will make decisions about where to allocate memory. And you can see I've got package cache size in a different color here. That's mostly because when I run STMM, I will almost always put a limit on instance memory, especially if I'm on a multi-instance Linux system. And then I will also go out and remove package cache size and tune package cache size manually. And the main reason for that is that I've seen STMM do badly with package cache size. It used to be that it seemed like it gave package cache size too much memory, particularly in an environment where parameter markers aren't used properly. And lately I've seen it actually making package cache size the other way, too small, where it could use a little bit more memory and benefit from a little bit more memory there. So I prefer to tune that one manually. All right, and before we move on to transaction logs, Martin, did you want to go through your thing?
All right, I'll just take over for just a minute here. Thanks, Ember. Let me find myself, so to speak. What does this button do? Here we are. I'll show my screen for just a minute. Here's our little commercial. It's pretty much the same thing we put up. The one thing in terms of DBI is the founding sponsor of the DB2Night show. We've always made it a point of just taking a little bit of time to highlight the tools available from DBI. And I think the best thing that characterizes how DBI works is it's not only a monitoring tool, but it's also something that helps you tune your environment and make good use of resources. So a chart like this shows you what's going on and it helps you ensure service levels in this day and age. Is not only do you have to find problems, you have to understand how things are performing and whether or not you're delivering the right level of service to your customers. And with that, I will end the commercial and turn things back over to you, Ember.
Okay.
There we are. Back on you. Great. Seeing your screen again. Thanks.
Great. Okay, so transaction logs. There are several different things I look at with transaction logs. One thing I look at is the frequency of archiving. So there is some overhead in archiving transaction logs. So I don't want a database to be churning through a lot of transaction logs to archive. And what I've got on this slide is I'm actually showing you the results of SQL that I use to generate a histogram. And this SQL is the same SQL that's available on my blog as well as in the Jupyter Notebook if you want to download it. And the transaction logs here in the first case, you can see that in almost all hours I have 0 to 5 transaction logs archived. So that tells me that in this case, perhaps my transaction logs are a bit too large because it's taking the database a long time to get through them. I do have a few places where I have more, and that's often things like an online reorg or something like that that is a transaction log hog. On the database on the right here, you can see that instead we have quite a variety of different values for the number of logs archived per hour. And in some case, the kind of the middle we're seeing of this shape here is somewhere in the 50 to 80 transaction logs per hour. And that's a bit high. If I'm looking at if I'm looking for my ideal value, I would like to see approximately 1 transaction log every 15 minutes. I can see higher numbers in particularly busy databases, but in general, I'm not looking to see dozens per hour. I would rather see under 12 per hour if I get my choice. Now, this isn't a super high priority thing. It's not that this is going to be the one thing that kills your performance in most cases, but it's just something that to be aware of and to be looking at and thinking about when you're sizing your transaction logs. More important for performance is the log buffer size, and looking at what your, the main things you're going to look at here are the log reads and the log writes. In this case, I am querying them from monget transaction log, which is a great table function to look at this sort of information. And what I'm looking for is I'm looking for log reads to be very small or 0, while I'm looking for log writes to be large. And this kind of satisfies that for me, because I have, let's see, I have 468 million log writes and only 933,000 log reads. So that's a decent area for me to be in. Your log buffer is one of the most critical areas for performance. So this is always something that I look at and always something that I dig into to try to figure out if I can help it. When I'm looking at tables, there are several things that I look at. I look for tables that are not used. A lot of us create a temporary table to do something. Maybe it's to load some data, maybe it's to copy some data. You know, there's a lot of times where we create a table that's not used, and 5 years later, it's probably still there because we didn't go out and delete it after we were done with it. And it's a situation where I actually had a colleague see a scenario where they were sued over some other things, and this was one of the issues that they brought up in that, was that there were all these tables that were created for a short amount of time and then never dropped. I don't think it's a huge issue overall, but I do think it's nice just to make sure that you're keeping your database cleaned up and getting rid of things that aren't used. I look at largest tables just so I'm aware of those while I'm going through and doing other things with the database. I look at the most used tables, so the ones that are scanned the most or read the most. I look for empty tables. That's more for custom databases than for vended databases, but sometimes somebody created a table and then they never really ended up using it. And a lot of times you'll see a lot of those, and it's nice to keep those cleaned up as well. One of the things that I've started checking, one of the first things I've started checking when I come into an environment with HADR is to see if there are tables that are valid on the standby. Invalid on the standby. So if you do a load into a table on your primary and there isn't a copy file available to your standby, then that table will become invalid on your standby. And then when you try to fail over, not only will the table be empty, the only thing you can do with the table on the standby at that point is drop it. And that might be okay for some cases, but you generally want to do everything in your power to prevent that from happening. One of the worst recoveries I've ever seen, we had an issue with HADR. HADR failed about 3 in the morning. And then about 5 in the morning, we lost 2 disks in a RAID 5 array. And it was an HADR server, so we failed over to the standby and discovered that one of the most important tables was not available on the standby. So what we had to do is we had to go back 2 weeks and restore a backup from 2 weeks ago, and then roll forward through 2 weeks of transaction logs to get that table back. So that was not a fun scenario. That was a 24-hour recovery, and we were able to get all the data back because we were very cautious in a number of different ways. But there were a lot of failure points there where we might have been in a lot more trouble than that. And it's not very fun to go through a 24-hour recovery on a system where you expect to be able to fail over and expect the outage to be very short. So that's one of the reasons I check for invalid tables on the standby. I look for tables with constraint issues. There are a lot of times where people have taken tables out of check pending by telling it, hey, I checked it, without doing the full checking, because it's so much faster, and it can be years later that you're still in that state. And I would much rather see all the tables in a fully checked state. So that's one of the things I query for. I'll query for tables with lobs to see if they're in properly configured table spaces. databases and to see if we've done long lob data reorgs on them at some point, and maybe even to go as far as to ask about inlining lobs and what they might want to be doing there. I'll look for tables with compression because sometimes people start using compression and they don't realize they're not licensed for it. That should be less of a problem in 11.5 with the new licensing model. However, it's something to be aware of. I'll look for columnar tables. Even if you have a blue database, sometimes you have both a mix of row-based and column-based tables. And I've seen scenarios where the default table space is a 4K page size, and so columnar tables end up getting created in a table space with a 4K page size. So that's not a very performant solution to have that happen. So that's something that not only do I check for in a health check, I actually run a monitor when I have a blue database to look for that scenario and alert on that scenario so that we can address it on a more proactive basis. Data pruning is one of my pet things. All else being equal, a smaller database is faster than a larger database. And a lot of times we end up with a lot of data that nobody is actually really using. And in that case, we want to look to data pruning or data archiving. Can we delete the data entirely? There are absolutely tables in databases where, in web server commerce databases, I can think of one table off the top of my head where the data is completely invalid and never used again after 10 minutes. And it generates, in most databases, a couple million rows a day. So making sure that you're going out and pruning that data and getting rid of that data that will never be used again is very important because it makes it so that everything else runs smoother. A lot of times I'll start with a list of the large tables as a good place to start on that and to start the dialogue, because the decisions on data pruning are business decisions. We have to ask, can we delete abandoned carts if it's an e-commerce website? You know, it's often a discussion we're having on business objects and not necessarily on the database itself. But in any case, we need to define what the business's rules are for data retention and figure out whether that data should be retained in this database or in another database, because in some cases we're going to be moving it to another place. When I identify large tables, I'll also look at the timestamp or date columns in those tables and tables with transitory data. So this is one of the statements that I use to look at the largest tables by size. And you'll notice here that in addition to the table, the basic table information, I'll include a list of date columns and lob columns. And I don't just go for the overall size of a particular table. I look at the size in lob, the size in index, and the size in data, so I can understand where I've got data in that particular table. So if I look at this particular table, I've got a lot of data, a lot of size in lob, so I'm going to be asking questions about whether I need a long lob reorg or anything along those lines. All right, indexes. So my pet metric, if I had to pick one KPI that I'm most interested in on a web sphere commerce database or on an OLTP database in general, it's going to be index read efficiency. What index read efficiency is you take the number of rows read in the database and divide that by the number of rows selected or returned. And what you get back is a number. And that number tells you how efficient is the workload against the database. And you're looking for, if it was perfect, a perfect index read efficiency would be an index read efficiency as 1, because that would mean when I need to get a row of data from the database, I go out to the database and I read only 1 row. If you get a higher number, then it means you're scanning through more rows, and you're going to get a higher number in almost every database. So if my index read efficiency is 2000, that means I wanted to get 1 row of data, and I went out to the database and I had to scan through 2000 rows in order to find that 1 row of data. And that's obviously less efficient. And And so there's some metrics for OLTP databases. I consider it great if I'm under 10. And I've absolutely had databases where I ran under 10 on an ongoing basis. I had a Webster Commerce database where I was around 3 for most of the time. I did some analysis on this for a database that was a Webster portal database, and I actually saw a read efficiency of 1. And that was this year, and I was shocked. I had never seen a read efficiency of 1 before. Most environments, when I go, if they're having performance problems and I go into them, I'm going to see something over 1,000. And that just means that there's a lot of scanning of data going on in order to get to the data that is needed. So for an OLTP database, that's going to be one of the things I'm going to look most at. Now that number is going to tell me whether I need to dig more into what's going on. So if in the case of the index read efficiency of 1, that told me, okay, I don't need to look at SQL or indexes. I don't need to spend any more time on it. However, if it's higher, it's going to tell me there might be issues. So if it's higher, I'm going to do several things. I'm going to see if I can find bad indexes within the database, and those are indexes with a cardinality of 1 or with a very low cardinality, indexes that aren't used within the database, because every index that you put in a database, maybe it helps read your read processing, but it doesn't necessarily help your insert and update and delete processing. I'm going to find missing indexes. So I'm going to look for tables with 0 indexes. That's one of the things that's very easy to go out and say, okay, here's a table that doesn't have any indexes on it. And usually those tables are those temporary tables that somebody created once and has never dropped, but sometimes they're tables that are being used and that need indexes to help them. I'm also going to look into SQL review. And we're going to talk in more detail about what that means. Basically, I'm going to be looking for missing indexes that should be there by reviewing SQL. And then while I'm looking at indexes, I'm also going to build awareness of important indexes by looking at what indexes are the most used within the database. So when I'm looking at SQL, first of all, I'm going to figure out how in depth I need to go with SQL analysis in a particular database. And there's several things that go into that. One, if the client is reporting a performance problem, it's fairly likely that I'm going to spend some time on SQL analysis. Secondly, if I've gone out and found that index read efficiency is really bad, if it's not where I want it to be. And also if I'm seeing issues with IO wait time or asynchronous write percentage, those can also be indicators that I would need to go out and spend some time with SQL. So one of the first things I'm going to do is I'm going to find problem SQL in the package cache and report on it. And assuming that SQL analysis is in scope or partial SQL analysis is in scope, I will do it as part of a health check. There are some health checks where I will say it's just out of scope, or I will say we need to spend more time than I can spend on it. It just depends on the particular environment. So this is a query that's out there on my blog as well. I go out to my blog entry on this fairly frequently to look at this and copy it and paste it to some new system or something along those lines. This is what I use to find problem SQL for DB2 9.7 and up, all the way up into the 11s. There is a version of this out on my blog for 9.5 as well. It's really kind of difficult to get before 9.5. So this SQL, you know, if you want to spend more time on it, basically the idea is to find what statements consume a high percentage of certain resources. So what statements go out and use a lot of CPU time or a lot of rows read time when compared to all the other statements in the package cache. So I'm not going to go into too much more detail on this here. I've actually got a whole nother hour-long presentation that I'm doing at iDoug North America this year. I'm hoping to do at iDoug North America this year. They haven't accepted presentations yet, but I'm hoping to do at iDoug North America this year that I did at iDoug EMEA on analyzing SQL using Jupyter Notebook that goes into this in a lot more detail. When I'm doing a health check, I'm always asking questions about high availability, disaster recovery, and backup and recovery in general. In general, this is one of the areas of the health check that I usually can't just query to find the answers. It's really one where I need to be talking to the people who are involved to understand what's going on. And one of the questions that I'll ask is, what's your RTO and what's your RPO? And the most frequent answer I get to that is, what's an RTO? And I think it's very critical for DBAs to understand the recovery time objective and the recovery point objective, so that we can discuss it and make sure that we're meeting the goals there. I come into a lot of environments and they say, oh, we need 5 nines. Or they say, we need active-active, and they don't necessarily understand what that means or the cost associated with this. So this is a chart that I have for my own knowledge and my own discussion so that we can talk about what that means. I find it particularly ironic when I come into a client and they say, oh, we need 5 nines, and I ask what they've got now, what, you know, the solution that they have now. And the solution that they have now is something that is just barely 1 9. I mean, it's something that's not very performant. There's no high availability. You know, it's just a DB2 server, you know, which, yes, DB2 can be up for 5 years, but it's a matter of going out and understanding where they are, where they want to be, and are they willing to put the money behind that. With HADR, you can get really close to 4 nines. You just can't quite make it for the most part. So you can get really close to 4 nines with HADR. If you really need a guaranteed 4 nines or 5 nines, then you're really talking about pure scale as something that you're going to need to be discussing. And then the other question that I ask is, has your DRs or your recovery strategy actually been tested? Have you done something here? So recently with a client, I came in for a health check and was having these kinds of conversations with them, and they said, our SLA is 24 hours. So we are a backup and recovery. That is our HA strategy. We don't need an HA strategy because we can be down for 24 hours and it's okay. And this particular client was running on AWS, and they were affected on Labor Day weekend when AWS had some data loss. So they were affected by that. And that DBA spent the entire weekend restoring databases. He made the SLAs. Nobody was down for more than 24 hours, and they're still okay with that strategy. So if you're okay with a strategy like that, that's perfectly okay. It's just something that you need to be aware of what that really looks like. So backups, even if you have a high availability strategy, you still need backups. You need to know how and how quickly the backups are externalized, how they catch failed backups. I have come into environments and said, hey, did you know your backups have been failing for the last week? And they don't. So it's something that's important to talk about. How are the backup and transaction log retention managed? What is their recovery strategy for human error, which is often not covered by some of our high availability strategies? Is the configuration information and DB2 look and that sort of thing collected periodically so they have more than just a backup? Are file system backups appropriate? Are they double backing up everything by doing a DB2 backup and then backing up the data file systems and then backing up the backup file systems? You know, how many duplicate copies of the data might they have depending on how they're doing that? And are they backing up other file systems at EOS level, things like the wherever they keep their database scripts so that they can recover those if they need to? I do some querying here. I go out and I review the recent backups so I can see what's been going on. I'll often do a timeline with these, and it'll be really easy to see, oh, they've got a daily, like here it's very clear to see they've got daily online full backups at to disk at 4 a.m. every day. So that this is a query that's very useful for that. I look at the backup duration because in most cases, a long backup means a fairly long restore. It's good to review the bar stats from the diagnostic log and look for bottlenecks. This is where table space design can really come into play. And then there are other factors that can impact backup duration as well, looking at encryption, compression of data or the backup image, the speed of your database storage, and the speed of your backup device, and are those separate devices, and the network or connection to your backup device as well. I'll go through a fairly in-depth HADR health check in most cases, reviewing all the HADR settings, making sure that HADR target list is properly set. If it's a multi-standby, is the primary correct when it's failed over to DR, because I've seen situations where you fail over to DR and it thinks that the primary, the principal standby is in the other data center, and that can lead to some very bad performance. If reads on standby are used, is the licensing correct? Are they fully licensed for the standbys? If TSAMP is in place, are they using all best practices? Because there's quite a few out there and I discover new ones at least once a year. Is there a separate VIP for each database? Because with TSAMP, the way IBM has us configure it, there should be a separate VIP for each database, not for each instance. Do they have get TSA scripts on the servers so they're ready to collect information if they need to open a case with IBM? And then running the HADR calculator, which is part of, there are these 3 tools from IBM that can really help you figure out if HADR is impacting your performance. Maintenance is one of the biggest areas where I run into gaps, where people are not doing run stats and reorgs the way that I would like to do them. But this can be your own standards as well. The things I look for on run stats and reorgs is that they're being done on a dynamic list of tables. Sometimes people will create a list of tables and then loop through that list of tables to do run stats and reorgs. That list needs to be dynamic in some way so that when new tables are added, they are automatically added to the run stats and reorg procedures as well. Does it include system tables? I'm a big fan of run stats on system tables. Maybe, theoretically it doesn't need to happen as often as run stats on everything else, but it's easier to just include it as you go through. Order of operations, making sure you do run stats, then you do reorgs. We'll talk about that on the next slide. And then with run stats, respecting profiles in case you try to do some more complicated statistics things. Are you gathering distribution statistics? Are you enabling automatic statement statistics for those real-time stats that actually are very beneficial? But automatic statistics in general aren't enough for me. I see things get missed when that happens. So if I'm doing automatic statistics, I'll also run a full run stats once a week. And not forgetting statistical views in anything that you're doing here. That can obviously be a part of automatic statistics, but it should be a part of your other scripts as well. Reorgs, making sure you're doing targeted reorgs based on reorg check. A lot of places where I come in, they're just reorging every table whenever they do reorgs. And that's just more work than is required from the database. I look at reorg check, and I'd like to do reorgs so that I'm not reorging all indexes on a table based on the F4 formula, unless F4 is flagged on a clustering index, and pay attention to the different reorgs needed for F7 and F8, and being aware that if you're doing in-place or online table reorgs, then you need to do index reorgs as well, because those are not handled like they would be for classic reorgs. Also being aware that online reorgs aren't really fully online. I've got some good blog articles out there on what I mean by that. The database order of operations, you have normal database activity going on all the time. In most of my environments, I don't get the opportunity for an offline anything. So this is online in most of the environments that I've supported. First, you start off with run stats on all tables. Then you do a reorg check. Then you do a reorg of the tables or indexes that need it based on reorg check. Then you need to do run stats again on any tables that you reorged. Then I like to do a DB2 R bind and a flush package cache. and then back up the database. And the main reason backup database is in here is because it makes a lot of sense to me to have all of this completed before I back up my database, even if it's a day before, so that when I restore my database, I don't have to think about doing all of this work all over again. So doing the health check on database maintenance is very much a trust but verify kind of thing. Ask for the details on the strategies that are used, discuss the reasoning behind the strategies, because there are absolutely edge cases and scenarios where something else makes sense. Excuse me. But also verify. Try to get your eyes on the scripts that are used to look for that are used so that you can look for holes and see if there are any problems with it. Look for script failures if you have access to the script output, so you can see if there are things that are not happening that that should have happened. Review the last stats time in syscat.tables. Use that to look for tables that are getting missed. You can query PD get diag history to review all stats runs, and that's a link to my blog article there on what that looks like. You can query or review your database history for recent reorgs. Make sure that there are some there to make sure that everything is lining up. Look for statistics on statistical views. So I've got I've seen all of these scenarios. I've come into environments that meet all the best practices, and on the other end of the spectrum, I've come into environments where there's absolutely nothing being done as far as run stats and reorgs go. And these are both really critical for ongoing performance. The DB2 diagnostic log is critical to review when you're doing a health check. Some people don't look at it at all, and it's something where it needs to, even if it's not automated, or even if it's just somebody looking at it, it's something to look at when you do a health check to make sure there's not any ongoing errors in there, anything that's sticking out and staying there that you want to be aware of. The things that I look for are critical or error messages, errors on the HADR standby that might indicate improper loads and inactive tables as a result. Lock escalation, package cache overflows, other memory overflows, and generally just a scan to look and see, are there any errors that are being generated on a regular basis that I might want to look into more. Also making sure that the diagnostic log doesn't go back to the beginning of time, that it's regularly cleared or rotated, whether you're doing that through the settings that IBM provides you for that in DB2, or whether you're using DB2 diag-A to archive it on a regular basis, or some other method. I'm a big fan of a monthly archive of the diagnostic log so that I have some historical data to go back and look at there. I know plenty of people who have other preferences there, and that tends to be a little bit more of a preference than a requirement, as long as you can get back to that older data in some way. So using Jupyter Notebook for health checks, I have coded Jupyter Notebook with my health check. The notebook is available here on my GitHub repository. It has all the SQL for what we've talked about. Here, it does not have some of the visualizations. So that's something that's kind of intellectual property of Extivia, and so I'm not going into the visualizations of it. But it does have the SQL and the basics you need to get started. If you want to take that and run your own health checks, by all means, go for it. Use it. Do whatever you want with it. Just don't sell it. That's the main thing. The main thing that the license file says is use it however you want, improve on it, share it, whatever you want to do there. And there's also out there an HTML example of what the output looks like in one of these health checks that can be very useful for you to see, what it really looks like when you run it before you actually have to run it on your environment. There's also a book out there that's useful if you're getting into Jupyter Notebook to understand DB2 development with Python. It's free. There's an ebook URL and an example URL here for that as well. And then I wanted to talk quickly about what the health check document looks like. Just a couple of slides here to go through that. Generally, in a health check document, I'm going to start with a table of contents so somebody can go down to a specific section if they're looking for something very specific within the document. I'm then going to include a scope section, which includes things like what conditions was the data collected under? Did I collect it on one random Thursday, or did I collect data on an ongoing basis over 3 weeks? You know, how was the data collected for it? And that would include any challenges in that process, access or analysis, any limitations on what we could or could not include. And then I always have a summary section. And what the summary section does is it gives a narrative for executives, managers, and other non-technical people. It often calls out my top 3 to 10 items or areas to be fixed. Sometimes they're grouped into themes if there was a lot to be fixed. It lists all suggestions in a sentence or less per suggestion with action items, just a bulleted list of what needs to be done. And then there's a main document body that's really targeted at DBAs and technicians that really goes through the details behind all of the suggestions and all the stuff in that summary section. And then finally an appendix that's the supporting details. It's usually, for me, it's usually the raw output of the Jupyter notebook that includes all of the data and everything, not just the stuff that was important to include. So sample summary sections, these are actual sample summary sections from actual health checks that I've done. I've got 2 of them here for you so you can see how they might be different. In this particular case, I had 4 major suggestions, or 4 suggestions that I wanted to call out. There was nothing that fell into my major category. You can see how my suggestions are structured here. Medium, I say recommendation, and then what the thing is, and then the actual syntax for doing the thing. This was one that had some much more severe issues. There were a lot of major findings in this particular one, so I grouped them into 5 areas for the summary to make sure that that it was very clear, you know, what was important, and to include things that would catch the attention of the executives in this case, including, you know, that Social Security numbers, which are very sensitive data, were being stored in inappropriate ways, you know, things along those lines. And then it's important to not just hand this document to somebody, but actually present it, to actually go through. The way I prefer to do this is to copy critical findings into a PowerPoint, and kind of, you know, highlight what I want people to remember in that. In some cases, I do just go through and scroll through the document, especially if it's the 3rd or 4th health check, annual health check I've done for a client, something along those lines. The important thing to remember when you're working on the document is that different people want different things. Executives and managers generally want a magic performance wand that makes everything perfect. Sometimes they want proof that their people are doing things right, or sometimes they want proof that their people are doing things wrong. If you're lucky, they want an honest assessment of what they're doing right and wrong and how they can improve. Technical people, on the other part, most of the time they want validation of the things they've been asking to change for years. Sometimes as a consultant I can give that to them. Sometimes I can't give that to them. It just depends on what kind of sanity there is behind the things they've been wanting to change. Sometimes they want to learn from another expert in the industry. Those are kind of fun ones to teach while doing the health check. Sometimes they want to get another set of eyes on a problem that they've been battling to try to figure out what the actual issue is. Sometimes they want to prove that they're smarter than you. Those are kind of tough to deal with at times. And if you're lucky, it's an honest assessment of what they're doing right and wrong and how they can improve. So it's just important to be aware of those while you're writing the health check. And that's it. I am always open to questions on Twitter at Ember_crooks, or emails ember.crooks@gmail.com. I'd love to hear any questions you have now or any questions you have after the fact.
Thanks, Ember. I've been watching the queue for questions, and we really didn't get any today because, frankly, I think your presentation was so clear that people could just follow it along.
Well, thank you.
Absolutely on point, and it's also interesting too. I've hit an awful lot of all almost all the things you've talked about in terms of, and particularly the slide you have right now with what people want. Every now
Yeah,
and
you
then
know, I
yeah,
learn something new from every health check, so they're
you
they're
always
fun. You know,
do. There's always
there's always something. You know.
It's the ecstasy of our job. We get up and we get to solve a different problem every single day.
Yep, absolutely.
If you're solving the same problem over and over again, you probably aren't doing it right.
Right, absolutely.
All right, let me take over control and do our final wrap up here. Um, I just need to make myself a presenter. I will do that. It should be seeing my screen now. I'll move off that, and there's our final thing. And of course, the last big question we always ask people is, did you learn something today? This is a simple yes or no response that we like people to give us some feedback on. And I'm guessing that this is going to come out the way I expect. At the rate we're going, I think we're going to just close this quickly. It's been a longer show than normal, but as I expected, everybody learned something, 100%.
Nice.
Never gets better than that. So great job. Thanks again for supporting the DB2Night show and the DB2 community, Ember. And with that, I'm going to wrap it up quickly and let people get on with their lunch plans here on the great Eastern Coast, and let other people get on with their days, nights, and evenings. And we'll see you next time on the DB2Night show. Thanks, and please look for the replay on our website, along with hopefully Ember's slide deck, and we'll see you all again soon.
Thank you.
Thank you, Ember. Have a great weekend. Bye-bye.
You too.